In the last video, we have seen the refraction of light. We have seen the light bends when it travels from one medium to the other medium. The reason why the light bends is because there is a difference in speed of light between those two media. In this video, we are going to see what are the consequences of refraction of light. One of the major consequences of refraction of light is the apparent depth and the real depth. So in your board exam, you might even get a 1 marker based on this. So the point here is we need to know two terms. One is a real depth and another one is an apparent depth. Let's understand what are these two terms with respect to a phenomena. So for example, if a coin or any object which is placed in a denser medium, when it is viewed from a rarer medium, so let's say this is air and this is water, since water is denser than the air, so when it is seen from air, the coin appears to be raised. Even though if it is placed at the bottom, it appears to be raised. So this is a common experience. We might have seen many of these things. Whenever we place a food in a pond or in a tank, we see our food being raised. Or whatever may be the object that you keep in a denser medium, we definitely see that the object is raised above the real depth. So there are two terms. One is a real depth, another one is an apparent depth. What are these two terms? The real depth is the depth from the surface to the coin, the real coin, where it is actually placed. So this distance is called real depth. Apparent depth is the depth where when it is measured from the surface to the coin where it is raised. So this is an apparent depth. So these two distances are called real depth and apparent depth. Why does that happen? That happens because of the refraction of light. Let's understand how this coin appears to be raised. For example, consider a ray of light that is starting from the coin, because of which we can see. So let's take this ray of light. So the ray of light is coming from the coin and it directly goes and hits the water and air surface. When it hits the water and the air surface, it bends. It bends because it is now traveling from a denser medium to a rarer medium. So according to the refraction, if you drop a normal here at the point of impingement, so now the light bends away from the normal. So since it is going from a denser medium to a rarer medium, whenever light travels from a denser medium to a rarer medium, the light ray bends away from the normal. So it bends away from the normal and reaches the eye or the observer. Now if I actually project this ray of light, so it straight away it goes here. So that means my coin appears to be here instead of here. So the reason why it appears to be raised is because of the bending. If there was no bending, then the light would have actually traveled this way straight, and then even when we projected, it would have been observed only at this position. So the apparent raise is because of the bending of the light or the refraction of light. So what is the relationship between the apparent depth and the real depth? The reason why the real depth and apparent depth there are two depths is majorly because of the bending. So obviously those two have to be related to the bending or the index of refraction or refractive index. The major reason why these two happen is because of the refractive index, so they must be related to the refractive index. What is the relationship? This relationship is an important one. The relationship between apparent depth and real depth is mu is equal to real depth by apparent depth. So mu in the medium with respect to A. So mu in the medium with respect to A or simply mu in the medium. So it depends upon what is the mu of the medium. For example, if I increase the refractive index of this medium, instead of water, if I place a more any other liquid which is more denser than the water, then the bending will be more. So it depends upon the refractive index of the medium. So mu is equal to real depth divided by the apparent depth. And what is the shift? Shift is this distance is the shift. Where is the real coin and where is the apparent coin? The distance is the shift. Shift is nothing but real depth minus apparent depth. How would I get this distance? I would get this distance if I subtract this distance from the total distance. I would get this distance. So that is called shift. Shift is equal to real depth minus apparent depth. Okay, can I write the apparent depth from this formula as apparent depth is equal to real depth divided by mu? I can rearrange the term such that apparent depth is equal to real depth by mu. So let me write that real depth by mu. So real depth by mu, apparent depth I replace it with real depth by mu. Then if I take real depth common, so real depth is equal to 1 minus 1 by mu. So the shift, how much the shift? The shift depends upon the mu. Real depth anyway, it depends upon both real depth and mu. But mu is a significant factor which will affect the shift. If my mu is more, then I have, if it is more, then this is a smaller number and 1 minus smaller number is a bigger number. So I will get shift as more. So if there is more bending, then there is more shift. That you can see even from here. For example, instead of bending this much, if the bending is this much, then you would see the object here instead of here. That means there is a lot of shift. So it depends upon how much the light ray bends. If the bend is more, or the refractive index of the material, denser material is more, then the shift is also more. In other words, what we can say about the real depth and apparent depth is, real depth and apparent depth are whenever an object which is placed in a denser medium is viewed from the rarer medium, then the object in the denser medium appears to be raised. And then what is the relationship between them? Relationship between them is equal to mu of the medium is equal to real depth by apparent depth. You might get confused whether it is apparent depth or real depth. You can understand this way. Mu of any medium is always greater than 1, which we know. So if the mu is greater than 1, we also know out of real depth and apparent depth, real depth is the greater one. You can see from here, so real depth is always greater than the apparent depth. So since mu is greater than 1, real depth always has to be in the numerator, so that it is greater than 1, it is greater and it is lesser, then the ratio will be greater than 1. So you can remember that when mu is equal to real depth divided by apparent depth, and the shift is equal to, you can directly calculate either from real depth and apparent depth, or since apparent depth we do not really know, we cannot measure it, but we know where the real depth is by measuring the depth of tank. So we are converting everything into real depth. So shift is equal to real depth into 1 minus 1 by mu. So you can remember these two formula, and then you can remember how the phenomena has occurred. And one important thing is that you need to draw this particular ray diagram, because in your board exam this question was asked. So in the next video we are going to see what are the factors that would affect the real depth and apparent depth.